Hello and good morning, everybody. So audio-video issues, that's why we're all here, right? So that was a good start for that show. And actually, no latency, exactly. And so I'm Oliver Lietz, founder and CEO of nanocosmos. I've been in the business for 20 years already, so we could have done a party together with streaming media. I didn't know that. And I want to talk today about how you can solve your latency challenges with what we did in nanoStream Cloud with our unique product, H5 Live. nanoStream Cloud is basically an advanced low latency CDN. And there's a new buzzword I just learned a couple of days ago, which is called edge computing. So I didn't know that before. I guess that's what we are doing here. Let's see. So I will do a short introduction about that, and I will be there for your questions afterwards, if you want. There's a lot of discussion going on about latency and low latency and how you can solve that, and to enable really interactive live streaming use cases. To solve these requirements, we at nanocosmos created nanoStream Cloud, which is an end-to-end solution for ultra-low latency live streaming. It features our unique integrated H5 Live player for ultra-low latency delivery worldwide on all HTML5 browsers. And for us, this means ultra-low latency, 1 second, end-to-end, glass-to-glass, to really enable interactivity. With this ultra-low latency approach, it's possible to create true interactive live streaming use cases and applications. As in the past, broadcast-style applications have been using a one-to-many approach, like TV or OTT, which you all know, where latency doesn't matter and didn't matter, and interactivity wasn't a use case. Enabling low latency and interactivity creates a lot of new business use cases, which we see coming from our customers, which go beyond standard broadcast. So there are quite a few new applications like webcasting, education, auctions, and betting, things like which connect to existing broadcast applications like trivia TV, game shows, iGaming, monitoring, security applications, search and rescue, and quite a lot more. All where the interaction between the audience and the broadcaster is a key feature. So these are some examples of existing use cases which all rely on ultra-low latency live streaming. Let's go into more detail for a specific use case, which is interactive webcasting with audio-video interaction, which we did together with the New York-based company TalkPoint. And these challenges were to be solved there. That should be a plug-and-free solution, end-to-end, which is based on HTML5 as a web application. It should be ultra-low latency, which means in this case 1 second end-to-end. And it should globally scale to large audiences as well. What's the challenges for these interactive use cases? So delivery of interactive live streams is not trivial and requires full control of the whole workflow, starting from the live encoder to the streaming server or cloud service or CDN, down to the live player. So sometimes also called like the first mile, the middle mile, and the last mile. For example, for existing setups, you might use already encoding solutions like Flash Media Live Encoder, OBS, Wirecast, whatever, which already might add some buffering to the workflow and up to 1 second maybe already get lost in the encoding process. So that's why it's really important to consider the whole workflow end-to-end, starting from the camera down to the player. I'm going to talk about the first mile later again, but as the greatest challenge currently is the last mile and the playout, I want to start with that first, how we solve that challenge. Currently, existing CDNs all rely on HTTP-based delivery like HLS and Dash, which create long segment sizes and buffer sizes and do a lot of caching and lose latency on this delivery path. So that's latency values of at least 6 seconds or more, which of course is not interactive anymore. So that's the latency values we see. HLS is the standard use case for CDN-based delivery. It starts maybe around 60 seconds, which you sometimes see in TV-based applications, can go down to maybe 6 seconds. But that's going to be challenging already in terms of optimized encoder configuration and streaming workflow. So there has been the Rtmp format, of course, in the Flash world, which is now going away. And in the post-Flash world, there are not many options, and that's why even when you would like to go plugin free in the browser, you need to rely somehow on HTML5 compatibility. And that's what we did with the H5 Live solution, which is a combination of low latency HLS and other HTML5 standards. Let's go into more details. So the H5 Live player is running on all HTML5 browsers, which includes Safari on iOS. It's integrated with nanoStream Cloud, so it directly connects to the end-to-end streaming workflow. It's very lightweight and easy to use based on HTML5 and JavaScript components. Works on any browser or device and can also integrate with existing solutions. So you can reuse existing encoding architectures based on Rtmp and do the delivery with H5 Live, but you can also go end-to-end. And do all this for worldwide use based on our CDN for scalable environments. So H5 Live is based on different protocols or standards which we connect to. We see that as a new ULL or ultra-low latency live streaming playback technology which takes existing HTML5 standards, so it's not completely built ground up. It's connecting to existing standards like WebSockets, HLS on a low latency HLS mode, and progressive MP4 or fragmented MP4, the FMP4 standards. So there are some technical details you need to be aware of when connecting to browser environments. And this runs on all browsers. As I said, the player decides then which technology to choose, if it's on a Safari iOS browser or a mobile browser, web browser, desktop browser, whatever. So it's not the technology, of course, alone. It's the end-to-end solution, and our customers were increasingly asking for complete solutions, end-to-end, to cover the whole workflow and the distribution challenges worldwide. Therefore, we created nanoStream Cloud as an ultra-low latency CDN, which has worldwide footprint, which also includes the H5 Live technology. So this avoids heavyweight infrastructure setups, and you can use that for instant live streaming and directly use that for playback on browser-based environments. Basically, what a CDN looks like is similar to other CDNs. There's ingest servers, origin servers, edge servers worldwide. You have the upstream coming from the encoder, and you have the downstream going to the player. And as said, you need to have complete control over the whole workflow, so that's why we needed to create that on our own and could not use existing CDNs for that, because we are putting our software also on the edges to ensure the best user experience for the low latency playback on the players. And that also enables us to keep the player part very lightweight and easy to use to embed on existing web pages. So from the user point of view or the implementation point of view, it's very simple. You can use a JavaScript code snippet which connects to the existing stream, which is basically an ID which you create when sending the stream, and then you have a low latency playback element based on HTML5 on your web page. So based on this worldwide architecture, also the player then automatically decides which edge location to connect to. If you are in the US here and would like to stream something to Asia, then the origin edge locations are automatically chosen by the cloud system. So let's go back to the encoding part, to the first mile. How do we do that? As said, we also want to have low latency on that and plugin-free applications based on HTML5. What we use there is Webrtc. That's also a topic which is highly discussed and which creates a lot of confusion in the industry, because sometimes it's considered as peer-to-peer, or is it delivery or ingest or communication or whatever. What we use it for is for the broadcast case to replace the live encoder. And to have a look at the whole workflow then is that you can use Webrtc for ingesting your live stream into the cloud, which reduces the latency then compared to existing Rtmp encoders. This will be connected to the delivery system for worldwide distribution, and on the other side, on the playout side, you will use the H5 Live player, which is then not Webrtc based, but based on the other HTML5 standards I mentioned. So it's not a peer-to-peer solution on the delivery side. It's also not a peer-to-peer solution on the ingest side. It's more like a client-server solution which connects the camera to the ingest point. Also, the encoder you can use based on JavaScript, so some lines of code are enough to use that. And when you have a look at the end-to-end workflow, you have a encoder part, which is using HTML5, which uses Webrtc, and you have the player part, which is using H5 Live, both connecting automatically to the origin edge locations worldwide to ensure the best delivery workflow. So wrap up for the technical parts. On the ingest side, Webrtc, ingest to H5 Live. You can also use Rtmp to ingest to the server. That's also still a valid solution for using for doing ingest. Also, Facebook is doing that, or other vendors, and that still makes sense to use if you have an existing setup. You can use Webrtc if you would like to go plugin free in the browser, and the delivery part then is based on our H5 Live technology, which enables true interactive live streaming applications due to the low latency, which is then around 1 second. So how is it being deployed? As said, you can use it as a cloud service end-to-end, but you can also use it as a CDN to connect to existing architectures. And there are also hybrid approaches possible. We can work with you to enable custom integration enterprise environments, add kind of on-premise solutions to that solution if required for specific controlled environments. Let's give a future outlook. So what we did with customers, specific use cases, for example, 360 live video for virtual conferencing or fan engagement. And for controlled environments, we are able to also go below 1 second, so sub-second delivery end-to-end is also possible with that. So you don't need Webrtc end-to-end for that. You can use Webrtc in the beginning and H5 Live in the delivery side. So there's a lot of things which can be done based on this technology. Here's an overview of what we can bring to help you getting your live streaming challenges be solved. What does this mean? If we together completely understand the whole workflow, of course, then it's easier to provide good use cases and a good user experience, because it really matters on how exactly the use case is laid out and from the customer point of view. And if we understand that, that's usually how we work with our customers to understand what they need and then provide the right solution. They can use the existing packages which we provide based on the cloud service and H5 Live Player. But as I said, there are also additional services available to enable the best user experiences. So nanoStream Cloud and H5 Live allows you to go around the world in 1 second. If you would like to join us, you can meet us in the international zone as well. And I'll be today afternoon, I think 2:30 or 3:30, in the panel discussion, which is about low latency. I think it's written here, LS104, 3:30 p.m. Also here together with other industry partners. That was my presentation, and I'm open to your questions now.
All right, first a round of applause.
Thank you.
Oliver, thank you very much for leading us off with a fantastic Discovery Track presentation. And look at this, we got questions.
Thanks. So you mentioned that you guys are actually solving this latency problem through CDN, but you're talking about integrating a live player on the devices or on the platforms itself. What are you guys doing on the CDN to improve that last mile issue that you highlighted that in one of your initial slides, but then things kind of moved to the player. So how you are solving it on the CDN side, last mile issues itself?
So we created our own CDN basically, which is not only a CDN for delivery, but which is a rather platform which includes the software. So the player is included in that. And it connects to our edge servers on our CDN to enable the best user experience for this latency challenges. So it's not working on a third-party CDN, but it's our own.
Yeah, but how do you still get away from the last mile issue? Like that's the part I was trying to.
Okay, then let me try to bring up the slide again. So you have the H5 Live player is JavaScript, which is in the browser and which connects to the H5 Live server, which is in the cloud. So the last mile delivery is then done with our protocol, which is based on WebSockets or low latency HLS, which is a unique fine-tuned protocol variant of existing standards. So it can really go down to 1 second for this latency requirements.
Okay.
Did that answer your question? So it's a combination of both. It's the client part, which is in the browser, and the server part, which connect together.
If I was to use a native layer using your CDN, how does that change the latency?
All right. The question was if he's using a native player
Instead of
Yeah.
the H5 Live player?
instead of your Edge5 Live player.
So you mean native player, you mean something built into an app?
Yeah, in the app itself, like the iOS AV player or the EXO player, the native players instead of your H5
So
Live player, can I still get benefit of your low latency algorithm from the CDN perspective rather than using your player?
So we also have native SDKs available for integrating that into iOS and Android, and you can do that in the web view or in a native environment. So that's something we can also provide. So, but of course, third party, it's basically HLS, but it would not be optimal for the latency point of view to use third-party players.
Okay. Next question, Doctor.
Do you have a DRM solution or DRM integration with your platform?
No, good question. No, we don't. But we can work with partners to enable this and to integrate that. So it's a bit dependent on the use case, what you would like to achieve. No, but you can maybe ask me after the presentation and can give you some ideas.
Okay, one more.
Hi, did I hear you right that you are going to provide in-house for Webrtc intake? Or is it still going to be only cloud solution?
I'm sorry, didn't get that?
So in your presentation,
Yes.
you have Webrtc upstream
Yes.
only to the cloud. Are you going to provide the licensing model so we can have it in-house?
So a bit depends on the use case requirements. So for larger enterprises, there might be a model which we can work together. So we need to discuss details about your requirements there.
Do I see any other hands? Any other questions? We've got some good questions for Oliver.
There's one.
Stumped him. Oh, we have one more here. Make it a nice, difficult one. Challenge him.
Don't worry.
You have this feature?
Hi. Do you have smart TV players as well? Or are you more focused only on HTML5? Because you've mentioned native SDKs for iOS, Android. How about smart TV platforms?
So we don't have smart TV SDKs. It might be possible to use that, or I know that it's possible. It's of course, very much dependent on the smart TV device and on the platform. Is it set-top box? Which features does it support? If it's HTML compatible with the features we need, then it might work. There is also a kind of emulation mode which you might use to connect to that, which might add some latency to that use case, but it's a bit dependent on the exact configuration and requirements.
Okay. And just another question regarding the HLS.
Yes.
I do understand how you would be able to achieve sub-second glass-to-glass with WebSockets. I completely understand that. You were able to achieve sub-second glass-to-glass with HLS as well?
Yes, because we don't rely on this HTTP-based push-pull, file-based chunking and caching system. So we do that based on...
Yeah, but still, a playlist is a playlist, right? So this must have an enormous impact on the overhead. I mean, the client will then be constantly requesting many times per second something, at least something.
That's what
right?
it not does. So that's...
It doesn't do that?
No.
No, okay.
So
but it is an HLS
Yes,
standard,
it is.
and it does not fetch fragments.
It does not fetch the, like in CDNs, this constantly fetching and pulling and pushing. That's...
Yeah, I understand,
one
but
of the-
HLS is a standard which is precisely that, right?
Not only that, of course. It's a standard which you can use for different...
So you're
purposes.
using it to push to the client?
No.
No. So you're not using it to pull and you're not using it to push, but it works.
Yes. Try yourself. So.
Thank you very much.
All right. Another round of applause for your good questions. Thank you, everybody. You've been fantastic.